I was going to try and do 28 slides in 20 minutes, so we'll see if we can be faster. And I guess there's a lot of talk about the data mesh at the moment, certainly amongst my customers, the very large enterprises. And to the extent that the person who came up with the idea, Zhamak Dehghani, has spoken at Kafka Summit as the keynote speaker, that being the major conference in the Kafka world. And there's like 4 main principles that we talk about. Data ownership, data as a product, data made available everywhere, and data governance. So, the data mesh, the idea, what we're doing is a synthesis of all of the ideas from a number of different enterprise domains. So we talk like from a data point of view, in the data warehouse world, people have been talking about data marts for a very long time. People like me who've been working in enterprise architecture space, we have great thoughts about domain-driven design and how that helps us build robust architectures. From the more developmental side of the house, people have been, one of the colleagues actually of Dehghani has come up with this idea of microservices, which has been a wave for the last maybe 10 years. And event streaming has become more and more and more common, and that's basically why I'm here. So if we talk about the domain-driven decentralization, the point of this is that we see that it's difficult to achieve success unless the data is owned by the people who understand it, who have the domain expertise. So historically, the way we've been building kind of analytics architectures is we lift all the data out of the domains and we put it in a data warehouse. So we have 2 parallel architectures, one to execute our business and one to understand our business. And we're seeing that this is quite rapidly changing from a shared data plane where the data stays in the domain and is used to execute the work of that domain. Now, an example. So if you imagine we build a microservices architecture where we have orders in shops and shipments and retail type stuff, right? And we have an inventory domain which is responsible for keeping track of what stock we have on hand and where it is. And we also have places to take orders, the customer-facing part of the business. Now, if an order doesn't have enough information or it has the wrong information that the inventory people can't actually facilitate that order, they have to communicate somehow. And traditionally in enterprise integration, what you would have done is that perhaps the inventory people would have gone and they'd have built their own service which enriches the data coming from the sales order, and then they would have solved their own problem. But in fact, if they go back to the originator of the data, the originator of the domain, and ask them to enrich the data on their side, you can solve the problem for all of the domains that are consuming the data rather than just the first domain that runs into the problem. Must be some animation here that I'm not aware of. There we go. Okay, so this is the data as a product is, I think, the place where the domain-driven decentralization is one of the key things, but data as a product is really the crux of this all. And the idea is to make, if we have these islands of control, which are our domains, to make the data like what we call the FAIR principle. It has to be findable, it has to be accessible, it has to be, I don't know what the last 2 are. Anyway, but basically so that you can trust that the data you're consuming or receiving from another domain is something you can use. And really that means you have to start thinking about it as a real product with a product manager, product lifecycle, right? Because otherwise data ends up locked in the domains. And this idea of a data product is really talking about a microservice for the data plane. So in the same way as we have contracts with microservices that we know how to invoke them and what data they give us back, a data product, again, has the data, it has some description, some metadata about the data, you've got some policies, procedures, and basically it makes it consumable by somebody else who isn't involved in that domain. And when we build this data mesh, we have to connect it somehow. And this is where the idea of event streaming is appropriate to data meshes, that the event streaming technology based on Kafka or similar technologies can be used to join up these islands of data so that when you expose your data product, you can expose it onto a Kafka as a Kafka topic, and then all the data that is produced that Kafka topic is basically that's your product, and you're curating that data, and other domains can consume it. And the reason why Kafka is a good technology to build this sort of interfacing on is that it is naturally decoupled. So the idea is that it's scalable both in space and time. You can both store very large amounts of data in it, so you could expose all of your customer data, even in a very large enterprise, onto a Kafka topic if you wanted to. And it also, so it can scale to very large amounts of data, but it can also, the way it works is because there is storage there, you write to the Kafka, and then many different consumers or clients can read back without having to do any changes upstream, which is very different from what we would consider to be traditional messaging technologies, where you send data and consuming it destroys the data. So we read data, really. So it's much more like a data warehouse from an architectural point of view in that sense, which is one of the reasons why data warehouses have had so much adoption. And the thing that's inside in the data product, it doesn't really matter what your choice of technology is. So just like with microservices, where you could use your choice of programming language to create your business application, with a data mesh, the idea is that each domain is independent. So they have their own agility, they are their own, masters of their own destiny. So, there's no real, you'll have one domain using Mongo, another domain using Teradata, a third domain using Oracle, whatever it is, possibly Snowflakes, whatever, right? And of course, you can also put your streaming into the middle of a domain. So some domains may not have any data storage in the traditional sense, right? We see operational data lakes where the data part of the data lake is actually Kafka. And the reason I put this picture in here is because in some sense you can have a very simple integration in and out of your data product using off-the-shelf connectors, so you can use your commodity data store of choice as the core of your data product, but then still expose the contracts on the sides with Kafka. And when we have a product, we have to be able to version it. So one of the things that the Kafka ecosystem did a number of years ago that hasn't occurred in any other messaging technology is this idea of schema evolution as a kind of first-class citizen, so that at the get-go, we know the schemas are going to change as we put data in for a longer and longer and longer period of time. Just like the DDLs in your database evolve, so can the schemas on your Kafka topics evolve. Okay, so self-service is one of the critical things to help with the adoption, because if we want to have domains that are independent, they have to be independent also from the human side of things, that it has to be easy for you to go off and consume or access a data product that's provided by a different domain. And this is an example of a project that one of the people in the office of CTO in Confluent was working on back when he used to do real stuff, where you got a surveillance system, and it used to take trade surveillance system. It used to take 9 months or so to get a new report built, because there was so much different interaction with other domain experts to understand what the data was telling you. This is one of the reasons they introduced event streams, but in fact, what they were really looking for was data products. And there are no data mesh products per se, right? There are people. It's not a technology problem really. It's a people problem and an organizational problem that we're trying to help people solve. So what I've seen is that pretty much any of the customers I've worked with who are adopting this approach tend to build their own self-service. But what we need to do is the technologies that are enabling the mesh have to provide APIs to allow you to build. Like obviously this is a toy example, right? But ING have built a really sophisticated one of these. Amex, American Express, they've built a and they've talked about it at Kafka Summit in the past. And there are two problems to be solved here. There's the classic Lambda problem that you have both real-time and batch flows, that you want to be able to take large amounts of information and analyze them. Classic ETL data warehousing way of looking at things. And also you need to be able to process, or you could possibly process transactions in real time. And usually that leads to two systems. So you would have had a Kafka plus a Hadoop, or a Kafka, you might have had an MQ plus a data lake. We are seeing convergence, that the technologies are fast enough and the storage is big enough that we could conceivably adapt a Kappa architecture, which is the same data processing and the same storage engines being used for both the real-time and the batch flows. We'll see more of that in the future, I think. And the final major piece is governance, because now all of a sudden, you as a data owner, the person who owns the data product, you can't just give your data to everybody. You have to be able to, we all live in big enterprises where there are compliance needs, where there are regulation. So you want to decentralize, but you need to have control. And again, this is something that can be built into the platform. You have to have standards. You have to have well-defined data owners. Usually the people who produce the data end up being the data owner, because that makes sense usually from an organizational point of view, but it doesn't have to be so. Okay. So for example, if we have a customer if we've got many different domains and there's bits of our customer in all of the domains, then how do we, you need some way of joining up the customer across the domains. And you might call this data virtualization, if you will, I think is another kind of pre-existing attempt to address this problem. Yeah. And when you want to have, one of the benefits of using the streaming technologies as the contract for the data mesh, for the data product, is that when somebody who is consuming doesn't understand or isn't able to process the data, they can keep on evolving their understanding by reconsuming the same data. So they can very easily do error handling. Anyone who's ever worked in finance, especially in transaction processing, when something happens and goes wrong in one of your counterparties, it's quite normal to replay the whole day to them, right? So basically you resend every transaction you process that day because somebody downstream had a database issue or their business logic was screwed up or something. And that's usually very painful, and you have to build a lot of process to make it possible, whereas with event streaming in the middle, they have control themselves. They can reset and replay from wherever they feel like. So it makes the data product more robust. And when we have this sort of behavior, where you do have independent pieces of the business sharing data with each other, one thing that the management layer and the governance entails is you need to be able to see who used your data, where did it go, right? And that's what we call lineage. And that's been, I think it's becoming more and more common. I think Microsoft just recently released a lineage product. You've got companies like Calibra, Apturia, there's a bunch of them. It's a very common thing. And we're doing a lot of work in this area as well. And this is pretty much my last slide. So just to recap. So, we see this as a very, all large enterprises that I talk to are thinking about this. How can we make our individual domains independent of each other and yet be able to cooperate to run the business? And I think data mesh is a very good way of doing it. Thank you all, and apologies for being late.